What's up, everybody? Welcome to Coding with Chaim. In this week's video, we're going to talk about using WebRTC technologies to allow us to share files from one person to the other person. And what's going to be really cool about this is we're actually going to get to share files that are actually really big in size. So for example, Slack only allows you to send a file that's up to like 1 gigabyte in size based on my Google research. And I think Zoom only lets you send files that are like up to 512 megabytes in size. Using the method that we're going to be going over together in this video, we're actually going to get to send files that are more than 20 gigabytes in size. If that sounds interesting to you, definitely stick around. Okay, so before we actually jump into the code, let me just mention two things. Number one, if you want to follow along, you'll find a link to the starter files down in the description box below. Number two, if you're not already familiar with WebRTC, I definitely suggest that you watch my other WebRTC videos before you jump into this one, and you can find a link to both of those down in the description box below. With that out of the way, let's jump into the code. All right, so as you can see here, we basically have a file called room.js, which pretty much lives inside of the client folder under source, under routes, and this is pretty much where we're going to be doing all of our work for the most part. So I pretty much have these four functions here. You'll see one of them is called handle receiving data, the other one is download, the other one is select file, and the other one is send file. These are basically the functions that we need to fill in to kind of get all the work done. These functions have nothing to do with the actual WebRTC sort of connection part, like the actual signaling between two different peers. This is pretty much handling the actual process of actually processing the file, sending the file, and actually downloading the file. So let's actually start writing some code. So as you see here in my JSX, what I'm rendering on condition, if we already have a connection established, this is basically something that I'm keeping track of in state. Once we actually have two pairs that are connected one to another, I basically set this to be equal to true, and when it is, I basically render an input that is of type equals file, and then I'm rendering a button that when you click on the button, you're actually going to go ahead and send that file. So the first thing we need to do is actually fill in the logic of what happens in select file. It turns out this is actually very simple because all we're really doing is we're basically just calling the set file method that I have within state. You can find that method right up over here. I'm basically saying const file and then set file from use state. So we're going to just be keeping track of the file within state. So then we'll just read out the event.target.files of 0. Basically, when you use a file input, you get a file list. And since we're only uploading one individual file at a time, we're just going to grab the first one out of the file list because there is only one, and we're pretty much going to set that on state. Once that's done, now the user will be able to actually press on this button to actually go ahead and send the file. So let's actually fill in the logic of what needs to happen when you're sending this file. But before we actually send that file and start filling in the logic of what's supposed to happen, let me just kind of go over quickly one little problem that we actually have. So if you remember, I was actually saying in the introduction that one of the goals that we want to have here, one of the things that we kind of want to do, is allow the ability to kind of send really, really large files. Now, of course, the problem with that is that if you start sort of allowing users to, download and send files that are, maybe 4, 5, 6, even 10 gigabytes, you can eventually start running out of RAM, running out of memory within the browser, and then you can cause your user browsers to crash. And even more so, the problem that we have is that WebRTC, at least in Chrome, I haven't actually tested this in other browsers, but at least in Chrome, when you're actually trying to send a file over the connection using the WebRTC connection, the file type can't actually be a blob. So when you're actually getting the file out of the input, what it actually is now is actually it's a type of blob, right? And blobs are not supported to be the type that you can basically send over the wire. So what is actually supported, one of the sort of supported types, is actually an array buffer. So what we first need to do is we need to convert this blob into an array buffer to actually get it ready to send over the wire to the other connection. The problem is, at a certain point in time when the files get so big, when you try to actually turn a blob into an array buffer, which based on the actual JavaScript syntax is extremely easy to do, the problem is that you run into an issue where it basically just flops. It just doesn't work. It can cause your browser to crash, and I've actually just had some sort of really weird cryptic errors basically saying that the process can't be accomplished because of some sort of security issues. But based on my research, it definitely comes down to the fact that the simple blob was just too big, and we couldn't just, convert it directly from in one shot into an array buffer to get it ready to send. So instead, what we need to do is we actually have to use a stream. And so the idea basically, of course, with a stream is that you're allowed to you're able to read smaller chunks at a time until you kind of read the whole thing. So at no given point in time do we actually have the entire file in memory, right? The blob itself is quite small, but the array buffer kind of gets a little bit bigger. So we can't have an entire array buffer in memory because that's going to kind of make us run out of memory. That being said, if we actually use a stream, we can kind of read chunks of it at a time and then send chunks over the wire. So therefore, we basically solve both of our problems. Number one, we're not sending a blob, which is not a supported type. We have to send an array buffer. So now we are. Number two, we can't send a very large array buffer because we're just going to run out of memory. So we're basically reading it as a stream and getting, sort of a bunch of chunks within a shot, and then only sort of sending each little bit at a time. Therefore, we basically never run out of memory. And that's kind of what we're going to be doing right now in the code of actually sending the file. So let's actually see that in action. Okay, so the first thing we're going to do is we're going to grab our peer. from peerref. So I basically have peerref.current. We could, of course, just keep using peerref.current, but it's just easier to use peer. So I'm just going to take that and apply it to a local variable. Now, here's where things get interesting. We're going to create this variable called stream, and we're going to say file.stream. So the file interface, or the blob interface that exists within JavaScript, actually has it in a method called stream. And you can literally just say file.stream, and what this is going to do is it's literally going to actually convert the blob into an actual stream, which we can then set up for reading. Now, the next thing we need to do is actually get a reader. So we're going to say const reader is equal to stream.getReader. Okay, and so now we actually have this reader object, which we can start using to read this actual stream. So now let me actually show you how that's done. So basically, the reader is an object that has a method called read, right? And this is basically going to be a method that returns a promise that's going to resolve with an object that basically has in it 2 keys. Okay, so we're just going to go ahead and call this object. Okay. Now, one other thing we need to do, because we're basically going to have to be reading this file recursively, right? Because this basic object here that we're getting from within the read promise, what it really contains is it's going to contain the actual data. In other words, a small chunk of the file as an array buffer. And then it's also going to include a property called done, which will basically be set to false and then be set to true until it's actually done, at which point there'll be no more data. And that's how we can basically know that we're kind of done reading, right? And so we need to basically keep calling this function recursively until such time that this property done is then set from false to true, so that we know that the file has now basically been done reading. And so this would look a little something like this, right? This is a basic recursive function. So what we're going to do is we're going to basically call a function. We're going to call this handle reading. And we're going to literally define this function within our send file function. Okay, so handle reading will accept value and done. So the done property, like I mentioned, will basically tell us whether or not the actual reading of the file is done. And then so long as it's not done, value will actually contain a value that is basically going to be a small chunk that is going to be our file reader, or our array buffer of the file. Okay, so basically we're going to handle if done. We'll get to that in a second. But if you're not done, here's what you're going to do. You're basically going to call peer.write. Okay, so this is the actual method that we're going to use and from within the actual simple peer API. Given an individual peer, you have a method called write, which allows you to basically send data off to the other peer. And then the other peer will basically listen out for an event that they're getting data. And then on that event, they'll actually receive the data that you're sending them. So we'll see that side of it in just a second. But for now, we're just going to go ahead and say peer.write value. And then we're going to go ahead and continuously keep reading this file until it's done. So once again, I'm going to reference our reader. We'll say reader.read, right? And then we're going to go ahead and say .then obj. And then we're going to go ahead and recursively call ourselves handle reading. And then we're going to go ahead and pass an obj.done and obj.value. Okay, and so now we basically come right up over here the first time that we're calling ourselves, and we're going to do the same thing again. So we're just going to go ahead and say we're going to call handle reading, passing in obj.done as well as obj.value. And so basically the flow is like this. We basically create the reader, we read it the first time. In the sort of .then of once the reader read its first chunk, we're going to get this object. At this point, we're going to have the done value and then the actual value. We're going to send it down to the handle reading function, which is defined here. And then the first time that this function gets called, it'll receive done and receive value. At this point, done will not be true yet. It's going to still be false. Therefore, we're going to write this little bit of chunk off to the other user. And then we're going to keep reading. And then we're going to basically keep repeating this function. We're going to keep recursively calling ourselves until such time that done is now going to actually be set to true, in which case we're going to be coming into this if check. Once we come to this if check, we're basically going to do the following. The first thing we're going to do is we're going to call peer.write once again. And now we're going to basically send. So one of the other types, besides for array buffers that can actually be sent using the write method, you can actually also send strings. But in this case, it isn't sufficient for me to just send the string, because I actually want to tell the other peer that A, I'm done writing to you, and B, this is the file name that I'm sending to you. So effectively, I'm actually trying to send them 2 values. And so the best way that I can think of doing that is actually putting that into an object. But an object itself is not a type that I can actually send using the write method. Therefore, I actually have to do JSON.stringify. So I'm going to do JSON.stringify. And then we're going to actually pass in an object. The first key will be equal to done, which we're just going to go ahead and set to true. And then we're going to say file name is equal to file dot name. Okay? And then finally, we're just going to go ahead and call return so that this function stops executing, and now we're basically done. Okay, so we've actually handled reading the data and sending it down as chunks to the other user. Now let's actually go to the sort of receiving end and start dealing with the fact of like what's going to happen once we actually start receiving data. So you'll see here in each peer, I basically have a peer.onData method or a peer.onData event, and then it basically references this handler receiving data function. So in other words, whenever someone is sending you data, your data event will get tripped up, and then in the function that you pass as a callback, you're going to actually receive that data as an array buffer, and then you're going to have to unpack that data and do with it what you will, right? So basically we're basically saying that when we receive the event of data, we're going to call the handler receiving data function. So let's actually go ahead and fill this function in. But before we actually start handling that, we need to just take a small deviation here and actually talk about something called web workers. So for those of you that are not familiar with what web workers are, they're basically a way for us to sort of be able to offshore sort of really heavy work to sort of a separate thread, if you will, right? So now, of course, JavaScript is obviously single threaded, which means that if you're really trying to do kind of really heavy work within your browser, what you can then end up causing to happen is you might block your sort of main UI thread. And then what ends up happening is your user will then have a really bad experience because there may be like a button that they may try to click on, but the browser won't even register that that button got clicked because it is now currently hung up doing some really, really heavy work. And so one of the ways that we can actually get around this is to use web workers. And a web worker basically allows us to kind of offshore some really, really heavy work sort of on like another process, like on another thread. And then we can kind of communicate between our main UI thread and this worker thread using sort of a post message function. So post message basically is a way to sort of communicate between either windows. Like if like you have an iframe and a main window, you can communicate between the two windows using post message. And similarly, you can also use that same post message function to actually communicate between the different threads. So in our actual function, we're actually going to be handling the receiving of the data. What we're going to actually do is we're basically going to take all the individual chunks that we're getting from reading out the stream of the file and already send it down to the actual web worker, because we're actually going to have to use a web worker to build up a blob. So the basic flow of what's going to kind of happen now, and I'm going to soon get into actually implementing this in code, but the basic flow of what's about to happen is we're basically going to actually, in our web worker, take all of the chunks that we have. We're basically going to take all the chunks, collect them into an array. So now we have basically an array of chunks to represent our file. But in order for us to actually have to download this file, we have to basically turn it back into a blob. That process of actually turning it back into a blob is a very expensive process that just takes a lot of computing power out of your computer. And so what's going to end up happening is if we do this in the main thread, we're ultimately going to lock up the UI thread, therefore causing the user to not actually have the ability to sort of interact within the browser while this is happening. So what we're actually going to do is we're going to sort of have a worker that's going to basically collect all the individual chunks, put it into an array, and then when the user is finally ready to download the actual file, what's going to then end up happening is the user will be able to actually hit like a button, say, yes, I want to download the file, because they've been prompted saying like, you know, you've received the file, would you like to download it? They're going to go ahead and actually prompt saying, yes, they want to download it. And then when they actually download it, now we're going to go ahead and tell the web worker, go ahead and take this array of chunks that you've been collecting, turn it back into a blob, and when that's done, go ahead and send me the blob, which I can then use for downloading. And all this will kind of happen in a sort of a background worker thread, which is not going to block our own UI thread, so therefore the process for the UI itself can still work smoothly, and we're not going to hang up any sort of user interactions. So let's actually see that in action. So we have to go to our public folder, which is going to be found inside of client. And inside of the public folder, we basically have to create a worker file. So we're going to go ahead and call this worker.js. So in here, we're basically going to go ahead and say let array. We're going to go ahead and create an array, which is going to basically be the thing that's going to hold all the individual chunks. This is going to be the actual array that we're going to kind of keep writing to. Then when you want to reference yourself inside of a worker, you basically have to use a self keyword. So we're going to say self.add event listener. We're going to listen out for message. Basically, every single time that the main thread will basically send us a message using the post message function, we're going to get an event called message, which we can then listen out for. We're going to receive the event object. Now the event object will basically contain the data that's actually being sent to us. So we're going to do the following. We're going to say if event.data is equal to the word download, basically saying that we're now ready to actually download it. We're going to handle it one way. Otherwise, if we're not up to actually downloading it, all we're simply going to do is we're going to call this current array .push, go ahead and push an event.data, which will basically represent a single chunk of the stream that we're reading out of the blob. That's what happens when we have not actually sent the word download to the worker. But now we're actually telling the worker to actually start the download process. What we're going to do is we're basically going to go ahead and say const blob. So we're going to turn this array of chunks back into a blob. We're going to new up the blob constructor, passing in the array that we just sort of built up in the else block. And then once that's done, we're going to go ahead and say self.postMessage. This individual worker is going to call itself, saying self.postMessage, sending a blob back to the worker or to the main thread that kind of spun up this worker. So this is again post message, the way that the worker and the main thread can kind of communicate between each other. So the worker is now sending the blob back up to the main thread, and then we're basically just going to sort of reset the array to be equal to an empty array so that we can kind of start working with future downloads in case there are going to be any more downloads happening between the pairs. Now coming back to our room file, we can now go back to the actual handle receiving function. And so now we're going to do the following. We're going to say if data, so the actual data packet is coming as a JSON object or a JSON string. So we're going to have to toString it, and then we're going to go ahead and say if it includes the words done or the word done, then we know they're actually done. And we're going to handle that differently. If it's not yet done, then all we're simply going to do is we're going to say else, if you're not yet done, go ahead and call worker, which we don't have an instance of this yet. So we're going to come out over here right on top of our file. We're going to say const worker is equal to new worker, and then we're going to say dot slash worker.js. This is going to go ahead and reference the worker file that we just created inside of our public folder. Now we actually have that instance of the worker, and so now we can come to our else block and we go ahead and say worker.postMessage. So again, the way that we communicate is going to be using this postMessage argument, and all we're going to do is we're going to pass in the actual data object that we just got from within handle receiving data, which represents one chunk of the entire sort of bigger file. Right? And then the worker will actually go ahead and scoop it up and put it into an array. Now, once we are in fact done, what we're going to do is we're going to say set got file is equal to true. This is basically going to allow us to now prompt the user saying, hey, you got a file, because we're not actually trying to show the user that they're in the middle of receiving a file. Once the file has been totally sort of read out and now they actually have it in memory within the worker, now we're basically telling them, hey, by the way, you have received the file. Would you like to download that? And so the way that we're kind of, setting that up is we have this method of state called setGetFile, which basically says, yes, you have a file. Would you like to actually read the file? So we're saying setGetFile is equal to true. Then we're going to go ahead and say const parse is equal to JSON.parse of this data that we are now getting. Whoops. JSON.parse data, right? So this data object that we're getting here is really just a JSON object. So we're going to parse it out so we can actually start reading it. And then we're going to say file name ref.current. So we actually have a ref called file name, which we're now going to use to actually store the file name that we have received from the other peer. So in other words, as the peer is done sending all the chunks, the last thing that it tells us is, hey, I'm done. Oh no, by the way, this is the name of the file, which is going to come in handy when we're actually ready to start downloading the file. So now that we have that done, we can actually go into the actual download file, and we can start actually processing the actual file to download on the user's machine. So the first thing we're going to do is we're going to set the got file state back to false. This way, if you want to send more files when the other file is done, we can then go ahead and reprompt the user that, hey, you've received another file. So we're going to kind of toggle that sort of on and off. And now what we're going to do is we're going to tell the worker.postMessage, we're going to go ahead and tell the worker, by the way, I'm done, and now I want you to actually start the download process. So this is going to tell the worker to go ahead and send us back a message. So we are going to listen out for the message that the worker will send us by creating another event listener here. So now within the main thread, we're now creating an event listener to listen out for any messages coming to us from within the worker. Once again, we're going to get the event object. And then within that now, what the worker will now be sending back to us is an actual blob. So now this blob, we now want to once again turn back into a stream. Okay, because the basic idea is that we are basically not able to download the entire file in its entirety at one shot. We basically have to do this in small chunks again because it's a very, very large file. So downloading it all in one shot will once again pose the same problem of us running out of memory, and we're just going to crash a tab. So instead we have to do this in sort of a stream-wise fashion. We basically take this blob that the worker is sending back to us, turn it into a stream, and then we're going to use a library that we have installed up over here called StreamSaver, which if you're using my boilerplate, you already have it installed. Otherwise, you can just go ahead and install it yourself. It's just the name of the library is just called StreamSaver. And then basically what is this going to do? This StreamSaver library allows us to actually save files locally on the machine, but doing it in a sort of stream-wise fashion. Therefore, we're never reading all the data out in one shot. We're sort of doing it in chunks, so we can still download really, really large files, but doing it in a way that won't cause the browser to crash. So we're going to go ahead and say const stream is equal to event.data .stream. So the event.data already represents the blob, so we can just go ahead and turn that into a stream. Now we're going to go ahead and create a write stream. So we're going to call the write stream file stream, and that's going to be equal to StreamSaver.create write stream. And then here we're going to basically pass in the file name ref.current to actually pass in the file name. And then finally, we're going to actually call our stream that we created over here from within our from the blob that we got from the worker, and we're going to call on it the method called pipe2. So we're going to say pipe2, and then we're just going to tell it to pipe to the file stream. So effectively here, we're creating a read stream. Here we're creating a write stream, and then here we're basically taking the read stream and we're piping it into the write stream, and then basically what's then going to happen is the actual file saver or the stream saver module will just start downloading the file to our local or to the user's local machine, but doing it in a sort of stream-wise fashion. Therefore, we're not reading all the data into memory in one shot, but we're going to do it in small bit of chunks. Therefore, we're not going to actually run out of memory. So that actually does it for all the code. Now let's go ahead and test it and see if everything works. Okay, so you basically see here I have two windows open, right? They're both in the same room. They're both at localhost 3000/room/some room ID. Both sides, both windows are in the same room, so they have a peer-to-peer connection now. So let's go to this peer over here. Let's choose a file. We're going to start with something rather small. So we'll go to my desktop. We're just going to choose this tiny little picture right over here. And let's go ahead and hit send file. As you can see, this user has now been prompted that they've received the file. Would they like to download it? The answer is yes, they do want to download it. Let's go ahead and download that. Open it up, and I'll pull this up to the screen right over here. And as you can see, we've actually successfully been able to send a file from one peer to the other peer. Now let's actually go ahead and send something a little bit bigger. I'm going to go back to my File Explorer. I'm going to go to my finished videos, and I'm going to choose my closures video, which, by the way, if you've not actually seen my closures video yet, you can find a link to that down in the description box below. But as you can see here, the closures video is already like 6.9 gigabytes in size. So this is quite a large file, right? Let's actually open this one up. And let's go ahead and hit send file. And now this will actually take a decent amount of time, so I'll see you back once this is actually done. All right, so as you can see, we now actually have the closures.mov file downloaded over here. So that basically means that we actually successfully sent the file from one peer to the other peer. We were prompted that the file is ready for download, and we downloaded it. All this took quite a while, which is why I didn't actually show it in the video. But now we can actually go ahead and play the video and see if it actually works. And here you go. You won't actually be able to hear any sound, but this is actually my closures video. And as you can see, it does in fact work. Well, that does it for this video. Hope you enjoyed it. I hope you found it useful. If you did, drop a like, subscribe, and I'll be back next week with another video.